Okay, let me record myself, which is always weird for me. Alright, so let's talk about how ozone is depleted in the stratosphere. Remember we said that we want ozone, or O3, in the stratosphere, but not in the troposphere. So remember, we had this weird little saying that it was good up high, but bad nearby, right?
Yes, no.
Alright, so long time ago, we started, well before you were born, we started putting these refrigerants, these chemicals in our refrigerators and in our AC units. And these refrigerants had a particular chemical in it. So I'm going to write that down. Hold on. Refrigerants.
Refrigerant, like with an F?
Yeah. Refrigerants in AC units were used really primarily in the 70s and 80s. And of course, that's going to be kind of revolutionary because obviously AC is wonderful. Everybody loves that.
You sound sarcastic.
No, I wasn't being sarcastic. Why do I sound sarcastic? I was being for real. Everybody loves AC. Alright, so industries began to use certain aerosols to make styrofoam. These chemicals, these products were called chlorofluorocarbons, or CFCs. Sorry, that's a C. Chlorofluorocarbons.
What's that last word?
Chlorofluorocarbons.
Carbon?
Chloro, like chlorine. And then fluoro, like fluorine. And then carbon. Because it's chlorine and a carbon and fluorine. Chlorofluorocarbons. Alright, so these were essential to the industry because they were, let me spell they right. They were non-flammable. Okay, so they were non-flammable, so they were essential. But see, here's the issue. These chlorofluorocarbons release chlorine into the atmosphere. So it turned out CFCs.
What's that word between 2 and BT?
Essential to industry because they were non-flammable. So it turned out these CFCs had an adverse effect on the atmosphere.
Who could have predicted that?
Right?
Putting chemicals in the atmosphere might be bad.
But, you know, AC is nice. Imagine living in Texas without AC. So these CFCs introduce the chloride ions to the atmosphere. So CFCs
That's the reverse, Miss Johnson.
Hmm?
That's the reverse or adverse.
Adverse. These chlorine or chloride ions would attach to ozone and tear it apart. That's interesting.
Is it Cl minus?
Yeah, it's chloride ions. Yeah.
You taught me that.
No, I didn't teach you that. Your chemistry teacher taught you that one.
Didn't pay attention.
Oh.
Yeah, girl.
So the chloride ions attach to the oxygen in O3, and when they do, they pull it apart. And so that forms ClO plus O2. So bye-bye O3. We just said O3 was important in the stratosphere, didn't we? Let me say that was like super important because, you know, living on planet Earth is nice without
Let's say Cl0
dying.
plus.
It actually says ClO.
What the hell?
Yeah. Chloride monoxide. Remember that?
No.
Mm.
Okay.
Jesus. Who was your chemistry teacher? Let me go beat that person up.
Miss Petit.
Yeah, mine was Miss Lewis. Go find it.
No, Miss Lewis is awesome.
I think Miss Petit like left.
Yeah, she had her baby because she had a heart condition.
Miss Lewis was such a good
Wait, did she die?
No, she's not dead.
Oh.
Okay, if Miss Lewis is such a good teacher, I don't want to hear
Jewish?
anything about not knowing stuff.
No, Miss Lewis was a good teacher. I just didn't pay attention.
I took my things like 6 weeks late, and she still took it in.
Okay, anyway, so, example. Here's what I need for you to understand. So here's O3. Again, what is O3? You guys tell me.
Ozone.
Awesome. Reacting with chloride ions. And it's going to yield ClO, which is chlorine bonded to oxygen.
Mm-hmm.
Okay, not clo. Plus O2.
Khloe Kardashian.
Mm.
Wait, but Miss Johnson, there's so much oxygen.
Yeah, so now we've got the diatomic form of oxygen, which is not what we wanted. We wanted the O3, right? We wanted the ozone.
Yeah.
Mm.
Well.
All right. Now, we're going to kind of switch gears, and that ClO is going to get popped off.
Popped up.
So we're going to break that ClO. So then, ClO reacts with another oxygen atom and forms diatomic O2, so diatomic oxygen. So what does that look like? So chloromonoxide plus oxygen is going to form the chloride ion plus another oxygen, O2. Now we have a chloride ion right there that can start all over again and attach to another O3 and do this entire process over and over and over.
Do you read these notes after something, or do you just do them out of what your head?
Sometimes I can do it out of my head, and sometimes I have to keep it organized and write it down
What
first.
about right now?
I have to keep it organized and write it down first.
Where'd you learn all this stuff?
I read.
Oh,
Wow.
what do you have a degree in?
I read. What's my degree in?
Yeah.
Biology.
That's it?
Oh, that's it, yeah.
Well, no, I'm not busy.
That's it? Oh my god.
Yeah, oh my god.
Jeez.
You don't know law? Jeez.
If only I did.
Then you wouldn't have to be a teacher.
No, I love being a teacher.
You could teach law.
Alright, are we good? Alright, so for some of us, we're looking at that and we're like, oh my god, chemistry, ow, it hurts. I'm going to go back and I gave you guys like a little worksheet and we're going to do it for the visual learners because I know that some of us are like, ouch, God bless you. Okay, so I promise you we're going to go back over it so that the visual learner people can see it a little bit better. Here's what I need for you to understand about the chloride ion. The chloride ion acts as what we call a catalyst. So let's talk about what a catalyst is. A substance that aids in a reaction but doesn't get used up. So let me write that down. Substance.
This is what AB chemistry, Ms. Johnson. Yeah.
Yeah, what?
Yeah.
That
When you
makes
change the glass.
sense. A single thing, baby. Shit.
If I write RXN, do you, never mind. I'll just write it out. So a catalyst is a substance that aids the reaction, helps it go faster, but is not used up. So it can keep going on and on and on. So ultimately, this becomes a cycle. So it becomes a cycle.
That aids.
Yes. So this is our catalyst right here.
How does AIDS kill a person?
Doesn't it slowly eat away at the cells?
It destroys the immune
Yeah,
system.
It kills the cells.
Like, you won't die from AIDS, you'll die from, like, some other illness, like a fever, a flu.
Okay, yep. So back to this.
I'm interested in AIDS.
Yeah, you teach biology. Tell us about AIDS.
Oh, yeah. So chlorine is a catalyst that causes or catalyzes the breakdown of O3. I just spelled that so wrong. Catalyst, sorry.
What's the catalyst modifying?
Modification.
That breaks down O3.
Modifying you?
O3's ozone.
Yes, it is.
Where's that on the periodic table?
It's not because it's not an element.
I know.
Okay.
It has oxygen. Oxygen is an element.
Yeah. You know dihydrogen monoxide is very dangerous.
Yeah, water is very dangerous. So this cycle continues.
The only AIDS I have is aiding and abetting. Reverse county funds.
You don't have to detect those guys.
What did you just say?
I'm
gonna have to detect the funds.
Okay, so this cycle continues until the concentration of ozone is so badly decreased that it is unable to absorb UV radiation. Cue in the hole in the ozone layer.
Miss Johnson, this is a completely random question. Why do they make us wear those blankets while they're taking the x-rays at the dentist?
The lead?
Because the X-ray radiation
Can't
can
get
be
the
harmful
budget.
for you.
Yeah, I know that, but like, what is the blanket do?
The blanket is a thick material that the X-ray waves don't have a high enough frequency to penetrate,
Okay.
so it protects your skin cells from it.
Oh, okay.
Is that right?
Yes.
Yeah.
I was wondering.
I mean, they could just put lead on you, but
No, like,
that wouldn't be
I
very
knew that.
pretty.
I knew that.
Yeah, wouldn't lead just be even worse than the X-ray?
No, it just would be ugly. Like, there's lead inside of the little thing, but they put it in fabric because we're Americans and we need things to feel good on our
And we're
skin.
extremely overweight.
Wait, but I eat my clothes. Is that bad?
Oh, okay.
Will that poison me?
I don't know. You might struggle to poop, but I don't know.
Oh, yeah.
Well, that boy in the treatment in that one movie.
My dog ate a shoe once. It took a while to come out. Yeah, it came out legs first.
You have a dog?
I have two.
Oh, what kind?
kind of dog eats a shoe?
A dumb one.
Oh, what kind of dog do you have, Miss Johnson?
I have my husband calls them summer dogs. Some of this, some of that.
I'm getting an English bulldog.
It says whole and ozone layer.
Hold in ozone.
Before the word.
Ultimate result.
Oh, I thought, okay. It looks like it's a
Okay, so, oh Jesus.
Ultimate. Oh, I thought it said climate.
Oh Jesus. Oh my God. I know I have bad handwriting. I'm sorry, y'all.
Oh,
That's Miss Johnson's fault.
I love you.
It's not even bad, we just can't read it. Wait.
That means it's bad.
It does?
What the?
I mean, I don't think it's bad, it's not like ugly.
I just can't read.
Yeah, it's not ugly, it's a little visible to read.
Awesome. Thank you. You guys are amazing.
I was just trying to make sure
right-handed.
That was a good try.
That's what it is.
Right hand game.
Oh, man.
No, he's left-handed.
All right. Hey, go on to topic 9.2.
Oh my God, his handwriting must be horrible. I feel bad for you.
I feel bad for you too.
You don't feel like all that's good? You know, like, Thomas has the best handwriting. Yeah, my handwriting is like 10 out of 10.
No.
It's literally it's 10 out of 10 handwriting.
Are we just
It's 10 out of 10.
Exactly.
What time are we going to Miss Johnson?
Just understand. Exactly.
Oh, wait, what?
You understand, like, my brain is thinking something at first, right? That's like,
Oh,
yeah.
I know.
We're
I'm
like
like,
two
you're not gonna be-
Doing 4.1.
The other one wasn't my
The other one that we did before that?
It was not that was good, so why would we do
So that's
that?
not, what is that?
Bum, 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 bum. No, it's the reduced.
Oh, gee.
What?
I was like, what?
So I just scratch out the 9.1 and the old one.
Yeah.
No, I just moved on to 9.2.
No, I'm talking about like the one from last time.
You can scratch it out, but it's gonna go with 9.1 anyway.
Which one is that supposed to be then?
It's still 9.1. That's fine.
So we put both of them and let
Yeah.
it submit it?
Yeah.
Confusing. Alright.
What if I just stop taking notes right now?
It would be a personal decision.
Are we turning these in?
Oh my God.
Listen.
Montreal?
Yes,
Why is that actually in Montreal?
It's not a place in Canada.
Yeah.
it is.
Yo, I'm so geologically correct. My parents love me.
Wait, does that actually say Montreal?
It
It
does.
says Montreal. It's the Montreal Protocol. You don't know
I'm gonna fucking love you.
it. Yes, you bro. You can talk smack.
Thank you. All right. The Montreal Protocol is. Thank you.
Review the student that's not highlighted?
Do I have those students?
No, the one who is not.
What about them?
One that's not highlighted.
Mhm.
She's not into AP classes, so we do not have a test order for her. Is she here?
Wait a minute. Which one is not highlighted? You mark out some.
That's the one.
Oh, she just came in. Achibuku. I just said your name so wrong. Achikuchu. I'm so sorry. Forgive me. We just need you to sign up on AP Classroom so we can order you a test for AP.
So do you know how to do that? Okay, and so this is Ms. Johnson's code for her to join. So do you want to write that down for us?
I can walk her through it in a minute. I'll be done.
Thank you.
Mhm.
And you're 100%, so thank you.
Alright, anyways, this is a piece of legislation that was enacted in 1987. I was a whole 7 years old. That was a long time ago.
Oh, wait. Okay. You're 7 years old. You were 7 years old in 19.
I already told you how old I am.
You're 20, right?
You're 40.
No, you're in
I'm 40.
She doesn't look a day over 17.
There we
So
go.
young.
Yeah, girl, Miss Johnson.
24 nations signed. This is a commitment to reduce the use of CFCs by 50%. And so back in 1987, we were perfectly capable of coming together to change our behavior in order to benefit the environment. In 2020, that's a totally different situation.
Huh.
We have Donald Trump in office. And he's stupid.
I don't know. He's the smartest man in the world.
Oh, God.
Yeah.
You're about to get canceled.
Canceling up, canceling. Oh my gosh, he's racist.
Wait till Twitter hears about this, Miss
Miss
Johnson.
Johnson. Wow, Georgia and North Carolina still haven't finalized their votes.
So this is a commitment to reduce CFC usage by 50%.
No, they're not.
Yeah.
No.
Yep.
No.
And then the door of the Trump, so I heard. Yeah, but they're cheating.
Where'd you hear it, Fox?
I don't know.
All right.
Donald Trump himself.
Yeah, Donald Trump told him Andrew. I'll be like everyone. Yeah, Trump told me that. Yeah.
No, hold on. He said Donald Trump himself.
Okay, ultimately the result is that the concentration of chloride in the atmosphere decreased all the way down to 4 parts per billion, which is a lot.
He really brought that. He destroyed it.
Miss Johnson,
Yeah,
was that successful?
yeah, I just said it decreased all the way to 4 parts per billion. That is very successful.
What is that? Use it by 50% by 4.
By 2000, year 2000.
Oh, that's a, oh,
Hey,
I thought
that's
that was
cool.
What is that?
CL stands for.
Oh Jesus, oh Jesus. CO stands for chlorine.
Oh my God, I was right.
Oh my God.
I want to close it. It's good.
Oh jeez.
I feel by the end of the year, Miss Johnson, you're gonna like throw a desk on.
You guys freaking chunk that.
I'm sorry, Miss Johnson.
I like chloroform.
I just like asking questions.
Is it true that
Did
chloroform?
I say 4 PBB? PPB? Like
Parts per billion.
peanut butter?
What does that say?
Parts per billion.
But it, yeah,
What does it say
that-
after 5?
is that
The
right?
result was chlorine, or chloride concentration in stratosphere decreased to 4 parts per
You
billion.
said chloride, but it's chlorine.
Chloride.
It's chloride?
Chloride, it's chloride when it's in the ion form.
Oh, that's in the ion form.
That's
It's
like
chlorine.
PPV.
It does.
Hey, you said PP.
Nice. Look at it.
Hey, I'm recording this, so
Oh.
I just want y'all to know how ridiculous you're gonna sound later.
I watched the video last
Devani,
night.
that was so funny. Nice.
Alright, so real quickly, I wanted to go over the natural depletion of ozone. So how does ozone naturally deplete? So every year, it's kind of seasonal, where we get a small hole in the ozone layer. And when I say hole, I don't mean like a complete hole where there's no ozone, it's just less ozone in that area. So natural, so back in the 1980s, yep, when Miss Johnson was in pigtails, we noticed a depletion.
It's not too late. You could still take this. You could pull it off.
I probably could.
Ah,
NASA noticed an ozone depletion above Antarctica.
Oh, God.
Am I spelling Antarctica right? I hope so.
I'm about to throw up.
I feel like there's a C right there. Antarctica.
I don't know what you're saying. Oh. Oh, what did I say?
I mean, you know I'm not wrong. She's kind of bad though.
This was found to be a seasonal occurrence between August and November. Ozone depletes a little bit over the Arctic.
Antarctica.
Yeah, there's a C after. There's ants and then arc and then tica. Okay, so why does that happen?
Because the spelling of the word.
Excellent. Thank you.
Oh, because it has Arctic in it.
Oh, Jesus.
Does it say found to be, Ms. Johnson?
Does that say N19?
Found to be seasonal, August through November.
What does it say before 1980s? Is that N?
Natural depletion of stratospheric
It's
ozone.
like little squiggle,
Oh,
like
So
around.
it's approximately.
Oh.
that's just a.
Oh, you guys are the smartest kids in school.
Listen, if I didn't have you 7th period, we would be cool, but
Okay.
do you have any other AP environmental period?
No, it's just y'all.
Why would people not take this class?
It's literally so easy because we have such a good teacher.
Yeah. Oh, thank you for that.
Yeah. No,
Because I'm only 17 years old.
Is that food on the second one?
It says found. All right. The extreme weather during the polar winter causes ice crystals to develop. And those ice crystals have NO, nitrogen monoxide. I'm just going to say nitrogen oxide. That buildup provides a surface for those Cl ions, those chloride ions.
The buildup.
The buildup of nitrogen oxide.
Does that say dragon?
Dragon?
Yeah, it says dragon.
Says dragon?
Yeah.
That does not say dragon.
It says dragon. It says
Where it
dragon.
says extreme cold
Driving.
weather.
It's
what
driving.
does it say?
Driving. It says driving.
It says develop. Driving.
No.
What
But
are
we
you doing
we
there?
can do it.
Honestly, don't know.
Where it says extreme cold weather and then that B word.
Oh, during. It's during.
Yes. And then proceed to like ice.
Guys. All right. So during the polar winter, what happens is that you end up with a lot of nitrogen oxide in the crystals and the ice crystals, and that provides kind of like a base for the release of Cl ions. Now those Cl ions are going to be released and go up to the stratosphere and do what they do, which is catalyze the destruction or the depletion of ozone. Okay, so let's write that in chemistry terms.
No.
Yes. So, typically speaking, chlorine is going to be in the diatomic form. But when UV strikes it, it's going to separate it into two atoms. We know that chloride catalyzes the depletion of O3. And so we start that particular cycle all over again. Another way that ozone is going to be depleted is with nitrogen oxide. When it reacts with ozone, it can also break it apart into nitrogen dioxide and oxygen.
Ms. Johnson, can you move it down a little bit? Yeah.
Alright. Yes, I'm sorry.
So like, the ozone gives an oxygen to the NO,
Yes.
nitrogen oxide. That's
Yeah.
like
So these are two ways that oxygen, natural ways, that ozone can be depleted. This is the natural way. The other way was us, right, using CFCs. Does that kind of make sense?
And then Cl in those brackets is chloride.
Yes. Remember, it's the catalyst. It's the one that's going to break apart the ozone.
But Cl is chlorine.
Yeah, Cl by itself on the periodic table says chlorine.
Alright.
But typically speaking, Cl is in the ion form. And so when it's in the ion form, we call it chloride.
Yeah.
Hey, y'all, I don't know what you're doing, but stop. Alright, so now I want us to go to the visual one because some of you guys wrote this down and you're like, I kind of get it, but then I kind of don't because chemistry is not our thing. So I want to make sure that we do understand this concept. I don't want anyone to be confused. All right. For the visual learners, for those that don't understand, I'm going to use different colors, I think, because I'm extra like that. So if you're extra like that, some of us aren't, and that's okay. It's really not okay, because I don't understand why you can't be extra. All right. Different colors. Yes. All right. Step one. Hey, hush. Children. Thank you. All right. So let's start with the natural formation of oxygen. So oxygen plus oxygen makes diatomic oxygen. O2. Who's confused? So 1 plus 1 equals 2. Together.
Really?
Crazy, I know. All right, now. That's so insane, I know. All right, now we get some UV. Gotta get some UV in there. Right? But not all 3 UV, because we have UVA, B, and C. UVA is not a big deal. It's UV, C, and UVB. Okay, so when those come in, so we got O2.
Is that a C or a E?
What did I just say?
I didn't see.
Yeah, I did just say C.
C and B.
I did. So, hey, part of this whole learning thing is shutting your mouth and listening. I know, it's crazy. Shh. So we know that these 2 O's here, hey, we're talking. Why is there talking? In that. Zip it. Thank you. So we know this is O2, right? And here's another O2, and then here's another O2. Cool. Now UV rays are going to break that O2 in half right here. And so this oxygen is going to go and attach to these 2 oxygens. And so then we're going to get 3 oxygens together And that's called,
Ozone.
excellent, O3 or ozone.
Autozone. Roll out. What's it autozone, not autozone?
I know.
Autozone. Just shut up. Oh, God.
Yeah.
Do you have autozone?
Yes.
Okay. Shh. How we doing so far?
Yeah.
Good, Ms. Johnson.
For my visual people that needed this. Hey, more people in here than want to admit needed it. Alright, so now I've just made some ozone. Yay. Alright, now I can break the ozone apart. This is the natural way of breaking it apart. I'm going to use some UV again. Got to get that UV. Get that UV in there. I'm going to color it. I don't know why, because I'm being extra. I mean, UV is not yellow because we can't see it, but whatever. So, O3 here, O3 there, and we're going to break them apart, and then they're going to obviously form
Ozone.
O2.
Can we kick Zach out of the class?
I second that.
How we doing so far?
What type of
Huh?
what type of UV is that?
It has to be UVC or UVB.
So it's only those three. Two.
Those two, yes. All right. Then we go back and we do it all over again. It's a cycle. So draw your arrow, go all the way back up to the top. It's a cycle,
Like the water cycle.
but not.
What is it then?
Not the water cycle.
Is it the oxygen cycle?
It's not the oxygen cycle either.
The carbon cycle?
Oh my. All right.
Phosphorus.
So that is the formation. Now turn the page.
The ozone cycle.
Hey, Zach. Oh, Zach, chill.
Is that a C? Oh, okay. C or B?
Yeah.
Okay. Okay, that's it. That's all I need.
All right. Guys, turn the page. Now see, this right here would drive me nuts, but some of you guys are like, yeah, I get it now.
Oh, this is easy.
I can't, if it were me, I couldn't do it, but I know that some of us need it, and that's okay.
This is UVB or UVC. Right?
Yes, UVB or UVC. So we get some UV. All right. I've got carbon in the middle, because this is a CFC, right? Carbon in the middle. And then these guys right here are going to be my chlorines. And these guys right here are my fluorines.
Cool.
Okay? So, I don't know. I got to draw it out, y'all, because I can't look at it like that. But, so fluorine, fluorine, chlorine, chlorine.
Is there
Sorry. So that's what it would look like. But some of you guys can look at it like that, and it makes perfectly good sense to you.
Is that a Lewis
can't
dot
see.
diagram?
Can you zoom in a little bit? Oh. What is this, chemistry class?
Right? What are we doing? So CL, I don't know if you can see that. And then CL. And yeah. How are we doing so far? We good? All right. UV is going to hit the CFC. You guys aren't listening. The UV rays are going to hit the CFCs, and it's going to pluck off, we call it pluck off, a chloride ion. So here's our catalyst, right? That chloride ion. Now that chloride ion is going to come along and attach to our O3 and pluck off an oxygen. Right?
You say pluck off?
I did say pluck off.
Thank you. I think that's
So chloride attaches to O3, takes off an oxygen. Got it? Okay? Then it's going to lose that oxygen. So this is another oxygen. And when it does, that other oxygen is going to react with another oxygen and form O2.
What's the oxygen?
Diatomic oxygen. Then the chloride is going to do it all over again. React with another
You zoom out a bit.
ozone. Gonna react with another ozone. Pluck off another oxygen off of ozone.
I'm way too blind.
Produce another O2. Oxygen and O2. It's going to lose that oxygen and do it again. And it's just going to keep doing it until there's no O3. Are there any questions about this process?
It sounds really,
Huh?
really useful.
You guys got to tell me. I'm not sure because y'all sitting there. I'm not sure if you're understanding what we just did. So chlorine or chloride is going to attach to O3. It's going to react with O3, and it's going to bind with an oxygen, leaving only O2. Then it's going to lose its oxygen, and then it goes back to being just chloride again, so that it can go again and bind with another O3. All right. Slowly but surely, you run out of ozone in the ozone layer, and it decreases to a point where there is literally a hole in the ozone layer. All right. These are all the equations that make sense in my brain. But anyways, so this is for you visual people, because you need it visual. And then this is for those of us that can read chemical equations, so that we can see it. Okay? So this is the formation of O3. Okay, so the formation of O3. Okay, this is also the formation or the breakdown of O2. Sorry, the breakdown of O3 into O2. And this is how CFCs break down O3. So chloride ion reacts with the O3 to produce chloromonoxide plus diatomic oxygen. This is the natural way that it's done. So this happens naturally over the Arctic. Nitrogen oxide reacts with ozone to make nitrogen dioxide and oxygen.
What does that say?
Natural.
Natural?
It says natural.
Okay. Natural with the two walls?
It says natural. Yes, natural. Natural. Over the Arctic. Natural. This happens naturally and seasonally.
I get it.
Naturally.
That says it happens naturally.
Yes, seasonally. Over the Arctic.
That's crazy.
This is not natural. This is anthropogenic.
Good point. Good English.
This one's anthropogenic. Not natural. Us. The Cl is the catalyst. 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 Okay, so this is a not natural or anthropogenic form of degrading O3. Now, oddly enough, this doesn't really happen anymore because we stopped doing this back in the 80s. And strangely enough, we were able to actually replace the ozone in the ozone layer. We were able to actually close that hole, which is really cool. But unfortunately, now we can't do anything else. That was like the first and last time we came together as human beings to help the environment. Anyways, these are the possible alternatives to CFCs. You got to know these. Okay, see, these are all the alternatives. I want you to add these to your notes. You can do it for homework. So just copy them and add them to your 9.2 notes. The ones we just took. Make sure you have these for your test. All the alternatives.
Even the bottom part?
This chart.
Okay.
All right. So, I think I'm good. You can put this in your notes. Are there any questions about how ozone is depleted in the stratosphere? So, when you guys take that test, y'all gonna be all right? Like, there won't be any issues. Everybody's gonna make 100 because you have no questions. You guys are amazing like that.
So we can submit the 9.1 now, right?
No, you have 9.1 and 9.2 now. You can put them on.
Done also?
You can put those on your digital notebook now.
Okay.
Your homework tonight is over global wind patterns. So what you're going to do is you're going to skip all this because I just did it for you. Thanks, Ms. Johnson. Skip all this and start at global wind patterns. Where is it? Past that. So you're going to start here, formation of convection currents. So start there. You might want to write that down. Or not.
Write that down now.
No. Actually, no, I lied. Start here. So start at atmospheric convection. That's what you guys are going to start with. And you're going to end at the ocean. So write that down. It's topic 4.5. Start at atmospheric convection. And you're going to stop when you get to ocean. That's what you're copying for homework. Atmospheric convection and stop at ocean. We'll do ocean later. You should write that down so you remember it.
So what was it?
Atmospheric convection. It's on there, yeah. It tells you where to start.
Wait, it'll tell you?
Yeah.
It tells you where to start in this
Yeah,
on Canvas?
yeah.
Okay, so I don't get it right.
I mean, I would write it, but that's just me. Maybe I'm extra.
I'll just look at it and then do it.
All right, cool. Yeah, sure. I wanted to show you guys something real quick. if I could. If I can find it.
Rest in peace, anymore.
There it is. Alright, so I wanted to show you guys this one. I don't know if I can make it any bigger.
That's crazy.
I'll add it to your notes on Canvas if it helps you learn it. Alright, can you... Will it open? Yes. I don't know if I can make this any bigger, but if you guys want to get closer and see it, I don't know if it'll get any bigger. But essentially that little green dot or the green spot is the chlorine attaching to the O3. Okay, so if you guys see that again, there's the CFCs. UV hits it, chlorine pops off, attaches to O3, takes an oxygen. That oxygen is then going to bind with another oxygen, make O2, and then chlorine starts all over again and does its thing. Does that help at all? Is anyone looking? Does anybody care?
Interesting.
Awesome.
Yep.
Thanks. You guys are amazing. I'm going to stop recording now.